What Andromeda looked like 10 billion years ago will change how you see the night sky. Okay, I need to tell you something, and I need you to stay with me here because this is genuinely important. When you look up at the night sky on a clear autumn evening, you can see something extraordinary with nothing but your naked eye. A faint fuzzy smudge about the width of 6 full moons. That smudge is the Andromeda Galaxy, 2.5 million light years away, the most distant object you will ever see without a telescope. And for most of human history, we thought we were looking at something peaceful, something serene, a beautiful spiral galaxy, much like our own Milky Way, a cosmic neighbor floating quietly through the void. We were wrong. What I'm about to walk you through tonight is something astronomers have only pieced together in the last few years, and it fundamentally changes our understanding of where we live in this universe. That beautiful galaxy you see in the night sky is a cosmic cannibal, a predator that has been devouring other galaxies for 10 billion years. And here's the thing that should give you pause. Here's the part that should make you pay attention. We're next. Stay with me here because this distinction matters enormously. This isn't science fiction. This isn't speculation. This is hard science based on years of telescope observations, computer simulations, and meticulous analysis of stellar archaeology. And what researchers have uncovered reads like something out of a horror novel. Here's what you need to understand. In January of this year, NASA released the most comprehensive portrait of the Andromeda Galaxy ever assembled. They stitched together over 600 individual images from the Hubble Space Telescope. 10 years of observations compressed into a single mosaic containing 2.5 billion pixels. 200 million individual stars resolved with unprecedented clarity. And when astronomers analyzed this data, they found something disturbing. Andromeda's history looks nothing like what we expected, nothing like our own Milky Way's relatively peaceful evolution. The evidence tells a story of repeated violent consumption. Smaller galaxies approaching Andromeda over billions of years, only to be ripped apart by gravitational forces so powerful they stripped away stars like meat from bone. Let me explain what that actually means in terms you can visualize. When a smaller galaxy gets too close to a massive one like Andromeda, something catastrophic happens. The gravitational pull becomes uneven across the smaller galaxy's structure. The side closest to Andromeda feels a stronger pull than the far side. This creates what astronomers call tidal forces, the same phenomenon that gives us ocean tides on Earth, but scaled up to incomprehensible proportions. These tidal forces don't just distort the smaller galaxy, they shred it. They rip it apart over millions of years, scattering its stars into long streams that eventually get absorbed into the larger galaxy structure. And Andromeda has been doing this again and again and again for 10 billion years. Subscribe to this channel right now and turn on notifications because what I'm about to tell you next changes everything we thought we knew about our cosmic neighborhood. In 2018, researchers at the University of Michigan made a discovery that sent shockwaves through the astronomical community. Richard Duza and Eric Bell were studying the faint halo of stars surrounding Andromeda. This halo is almost invisible. It extends far beyond the galaxy's bright spiral arms into the darkness of intergalactic space. And here's what they found. Most of those halo stars didn't originate in Andromeda at all. They came from a single massive galaxy that Andromeda devoured approximately 2 billion years ago. Think about what that means for a moment. Let that sink in. A galaxy so large it was the third biggest in our entire local neighborhood of galaxies, bigger than every single galaxy that has ever merged with our Milky Way combined. This galaxy existed for billions of years. It formed stars. It may have had planets. It may have had life. And then Andromeda ate it. The researchers gave this vanished galaxy a name, M32P. And here's the truly remarkable part. They believe a remnant of M32P still exists today. That strange, compact little galaxy you can see orbiting Andromeda through a small telescope. The one called simply M32. That's not a separate galaxy at all. It's the corpse. As astronomer Eric Bell put it, and I want you to hear his exact words here, M32 is a weirdo. While it looks like a compact example of an old elliptical galaxy, it actually has lots of young stars. It's one of the most compact galaxies in the universe. There isn't another galaxy like it, and now we know why. M32 is the surviving core of M32P, the indestructible pit of a cosmic plum. When Andromeda ripped M32P apart, the outer layers were stripped away and scattered into that faint stellar halo. But the dense central core survived, compressed, traumatized, but still intact. Now I need to tell you what actually makes this discovery so profound. For decades, astronomers believed that when two large galaxies collide, the resulting merger destroys the spiral structure of both. You get a bloated, featureless elliptical galaxy, a cosmic blob with no elegant spiral arms, no structure, no beauty. But Andromeda survived. It devoured a galaxy that was at least 20 times larger than anything our Milky Way has ever absorbed. And its spiral structure remained intact. The disk didn't collapse. The arms persisted. This challenges everything we thought we knew about galactic evolution. It suggests that spiral galaxies are far more resilient than we imagined, that they can survive catastrophic mergers and come out the other side still recognizable. And here's where it gets genuinely terrifying. Andromeda's consumption of M32P 2 billion years ago wasn't an isolated incident. It was just the most recent major feeding event. Further research published over the last several years has identified evidence of at least two distinct epochs of galactic cannibalism. One occurred within the last 5 billion years. The other happened much earlier, somewhere between 8 and 10 billion years ago. Stay with me here because this is where the detective work gets fascinating. Astronomers identified these ancient feeding events by studying globular clusters. These are dense balls of hundreds of thousands of stars that orbit galaxies like satellites. Many of them are ancient, formed in the early universe. And here's the key insight. When a galaxy gets consumed by a larger one, its globular clusters survive. They're too tightly bound to be destroyed, so they continue orbiting, carrying chemical and kinematic signatures of their original home galaxy. By analyzing the orbits and chemical compositions of globular clusters around Andromeda, researchers could identify which ones were homegrown and which ones were stolen, consumed along with their parent galaxies billions of years ago. Professor Garen Lewis from the University of Sydney, who co-led much of this research, described it perfectly. It's like drops of food coloring in a glass of water right after you add one. The structure of the dye is coherent, but after time it disperses and spreads out over the entire glass. The more recent feeding event still shows coherent streams of disrupted material. The ancient one has dispersed so much that only chemical fingerprints remain. Think about what this means. 10 billion years ago, when our own solar system didn't even exist yet, Andromeda was already a predator, already consuming its neighbors, already growing through violence. If you're finding this valuable, hit that like button right now because this story is about to get significantly more complicated. I need to connect some dots here because what happens in Andromeda isn't just interesting astronomy, it's a preview of our own future. You see, Andromeda and the Milky Way are on a collision course. For 100 years, astronomers have known that Andromeda is approaching us, moving toward the Milky Way at about 110 kilometers per second, 250,000 miles per hour, faster than any bullet, faster than any spacecraft we've ever built. In 2012, researchers using the Hubble Space Telescope measured Andromeda's motion with unprecedented precision. They tracked the positions of stars over multiple years, compared them to distant background galaxies, and calculated the trajectory. Their conclusion was stark. A head-on collision was essentially inevitable. 4 to 5 billion years from now, Andromeda and the Milky Way would merge into a single massive galaxy. Astronomers even gave this future galaxy a name, Milkomeda. Now here's where I need to tell you something that just happened, something that complicates this picture dramatically. In a study published recently in Nature Astronomy, everything was thrown into question. Researchers led by Till Sawala at the University of Helsinki ran over 100,000 simulations using the most current data available, including today, February 23, 2026. And they found something unexpected. When you factor in the gravitational influence of other nearby galaxies, particularly the Large Magellanic Cloud and the Triangulum Galaxy, the certainty of collision drops significantly. The current probability, about 50%. That's right. The collision we've been told was inevitable for over a decade may not happen at all. Or if it does, it might occur 8 to 10 billion years from now instead of 4 or 5. Think about the scale of uncertainty here. We can predict the behavior of distant galaxies over billions of years, but the gravitational dance of our local neighborhood is still chaotic enough that we can't be certain whether we'll be consumed or not. Now, I want to be clear about something important. If the collision does happen, it won't be the catastrophic event you might imagine. Stars are so spread out that direct stellar collisions are essentially impossible. The distances involved are incomprehensible. If our sun were a ping-pong ball, the nearest star would be a P about 700 meters away. What would happen is gravitational chaos. Stars would be flung into new orbits. Our solar system might be ejected to the outskirts of the merged galaxy, or we might spiral inward toward the center. The familiar constellations would slowly dissolve as the structure of both galaxies reforms into something unrecognizable. And Earth itself? By that point, the sun will have grown so hot that our oceans will have boiled away. Life as we know it will have ended billions of years before the collision even begins. But the atoms that make up you and me and everything on this planet, those will still exist. They might end up scattered across a new galaxy, part of new stars, new planets, maybe even new life. Drop a comment right now. Tell me where you're watching from. I want to know how far this is reaching, because what we're discussing tonight has profound implications for how we understand our place in the universe. Here's what most people are missing about all of this. We tend to think of galaxies as permanent structures, fixed points in the cosmic landscape, but they're not. They're dynamic, evolving systems that grow through violence, through consumption, through cannibalism. Our own Milky Way has absorbed smaller galaxies too. We're currently in the process of consuming several dwarf galaxies right now, including the Sagittarius dwarf elliptical galaxy. This has been going on for billions of years, but Andromeda's appetite is on another level entirely. Professor Dougal Mackey from Australian National University put it bluntly: Andromeda has a much bigger and more complex stellar halo than the Milky Way, which indicates that it has cannibalized many more galaxies, possibly larger ones. Knowing what kind of a monster our galaxy is up against is useful in finding out the Milky Way's ultimate fate. A monster, that's the word he used, and it's accurate. Now let me connect this to something even larger. What's happening in our local group of galaxies isn't unique. Galactic cannibalism is how the universe builds structure. Small galaxies form first, then merge into larger ones. Those larger ones consume others, and so on up the chain until you get massive elliptical galaxies at the centers of galaxy clusters. This process has been going on since shortly after the Big Bang. It will continue for billions of years into the future. And here's the truly mind-bending part. Because the universe is expanding and that expansion is accelerating, there will come a point when distant galaxies recede from us faster than light itself can travel. They'll disappear beyond our cosmic horizon, unreachable, unobservable forever. Some astronomers estimate that in about 100 billion years, the only thing left within observable range will be whatever emerged from the merger of local group galaxies, Milky and its remnants, a single island of stars in an otherwise empty void. Everything else will be gone. Let me leave you with 3 things tonight. First, when you look up at the Andromeda Galaxy on a clear autumn night, you're not seeing a peaceful neighbor. You're seeing a cosmic predator with a 10 billion year history of violence. That faint smudge of light contains the shredded remains of countless galaxies that no longer exist, stars that were ripped from their homes, globular clusters stolen from their parents, the evidence of repeated consumption stretching back to when the universe was young. Second, our own Milky Way exists in the shadow of this monster. Whether we collide in 4 billion years or 8, whether the merger happens at all or not, we share a cosmic neighborhood with something far more massive and far more aggressive than ourselves. The gravitational influence of Andromeda shapes our destiny whether we like it or not. Third, and this is the part I want you to really think about, everything in the universe, including us, exists because of processes like this. The heavy elements in your body were forged in stars that may have themselves been scattered by ancient galactic mergers. The solar system formed from debris that gravity pulled together over billions of years. We are here because the universe is violent, because galaxies collide, because matter gets churned and recycled and reorganized. The cannibalism of Andromeda isn't just history, it's the mechanism by which complexity emerges from chaos. It's how the universe builds the conditions for life. What happens next depends on forces operating over timescales we can barely comprehend. Billions of years, distances measured in millions of light years, gravitational interactions between objects so massive they warp the fabric of space itself. And yet, remarkably, we can see evidence of it all. We can study the stellar archaeology, we can run simulations, we can piece together the story. The Hubble Space Telescope spent 10 years building that 2.5 billion pixel mosaic of Andromeda. The James Webb Space Telescope is now probing even deeper. The Gaia spacecraft is mapping the motions of stars with unprecedented precision. Every observation brings us closer to understanding not just what Andromeda did in the past, but what it will do in the future and what that means for us. The night sky isn't static. It isn't peaceful. It's a battlefield where gravity determines winners and losers over billions of years. And right now, in this brief window of cosmic time, we get to watch. Make sure you're subscribed with notifications turned on because this story is far from finished. New observations are coming, new discoveries are being made, and the more we learn about Andromeda, the more we learn about ourselves. The universe doesn't care about us, but it did create us. And understanding the forces that shaped our existence, including the violence of galactic cannibalism, is one of the most profound things we can do as a species. I'll be watching, and so should you.